Hi guys, welcome back to school. I've got another lesson for you today, continuing on with the molecular shapes. I'm sure yesterday you saw the announcement from the government that some teachers and students will be going back to school on Tuesday. That definitely doesn't include you guys, so we'll be continuing on doing these lessons for a while. So yesterday we're looking at molecular shapes, such things as tetrahedral, trigonal planar, linear, trigonal pyramidal, and these two bent shapes here. And what we're going to be looking at today is how to answer these questions in an exam. So an example of an exam question will be on this page here, page 52. Here we have a molecule here, SO2, and I've drawn out the Lewis diagram for you. I don't like this question very much. They have drawn the Lewis diagram for you, which is good. But if they had asked you to draw the Lewis diagram yourself, you wouldn't be able to do it because we haven't gone over these dative bondings yet. But don't worry about that. All we have to do is name the shape. So the question says, explain the shape and approximate bond angle of SO2. So this is how we answer it. I'm going to just give you the answers. You don't have to do this one in your book. So first, there are 3 regions of negative charge around the central sulfur atom. This is the first thing you've got to write. The sulfur atom's in the middle, and as you can see, it has a double bond coming off it to the right to an oxygen, a single bond to this oxygen on the left, and it has a lone pair above it. These are all just regions of negative charge, and there are 3 around the sulfur atom. The next bit we have to say is that these regions of negative charge want to be as far apart from each other as possible. So we say these regions repel for maximum separation, and because there are 3 regions of negative charge, the regions of negative charge repel each other into a trigonal planar shape. Now these are the regions of negative charge are in a trigonal planar shape because they want to be as far away from each other as possible, and that means they have a bond angle of 120 degrees. So here is my hand, is the sulfur atom, and these are my 3 regions of negative charge around it. And as you can see, they repel each other to be as far away as possible, and the maximum distance they can be apart is 120 degrees. All right. Now, one of these is non-bonding and 2 are bonding. So I'm going to remove the non-bonding one here, and this is my molecule. It's going to look like this. There are 2 bonding and 1 non-bonding region. Therefore, the shape of SO2 is going to be bent with a bond angle of 120 degrees. So this is basically a little template of how to answer the rest of these questions. So ammonia, NH3, we are basically going to do the exact same thing as here, but down here for ammonia. So I'm going to draw ammonia on this thing here. So ammonia is NH3 pencil. Here is the N. Let's count out the valence electrons. There's 5 valence electrons. 1, something bigger than that. Pencil, circle. All right. 1 valence electron, 2 valence electrons, 3, 4, and then we double up there. So nitrogen's going to have 3 bonding electrons and 1 lone pair. Now I've got 3 hydrogens, This works. It's one hydrogen with one electron, two hydrogens, and three hydrogens, each of them with one electron. This is a very bad drawing, but that's all right. What happens now is that, there we go, these non-bonded hydrogens are going to bond with one of the non-bonded nitrogens, and we make a bond here. So I've drawn the shape, I've drawn the molecule NH3. Now we have to justify the shape of it. Where are we? Here, no, here. All right, so first what I'll say, we're just going to use this exact same recipe. There are four regions, 1, 2, 3, 4 regions of negative charge around the central nitrogen atom. These regions repel, these regions repel for maximum separation into a, I've given you the answer there, tetrahedral shape. Now there's four regions, let me use my 4 pens, which repel into a tetrahedral shape, okay? The final molecule isn't tetrahedral, but this is really hard. But these, this one's got to go like that. But they repel into a tetrahedral shape, as so, or close enough. Now, one of these regions is non-bonding. So we're going to take off the top one. And what we have left is this shape. So if I go back here, these regions repel for maximum separation into a tetrahedral shape with a bond angle of 109 degrees. Tetrahedrals, what's that bond angle of 109 degrees? However, there are 3 bonding regions, the 3 which are left over, and 1 non-bonding region. Therefore, the shape of NH3 with 3 bonding and 1 non-bonding is trigonal pyramidal. Yes. So that's how you do these questions. Yeah, pretty straightforward. Same thing for all of them. Carbon dioxide, methane, water, and nitrogen trichloride. And then over here we have the same sort of thing, but you're comparing 2 molecules. Here's one we did before, and here's one we did after. Once again, they give you a little recipe for doing it. We'll do the recipe together. So, sulfur dioxide has 3 regions of negative charge around the central sulfur atom. These regions repel for maximum separation into a trigonal planar shape with bond angles of 120 degrees. There are 2 bonding and 1 non-bonding region. Therefore, the final shape of sulfur dioxide is bent. You can say bent 3 regions, but really, because we've said it's got a bond angle of 120, that already explains it. H2O has 4 regions of negative charge around the central oxygen atom. These regions repel for maximum separation into a tetrahedral shape. So if there's 4, it's tetrahedral shape with bond angles of 109 degrees. There are 2 bonding and 2 non-bonding regions. Therefore, the final shape of H2O is bent. And then the last bit, comparing the 2. The shape of SO2 is based on the trigonal planar shape with bond angles of 109 degrees, while the shape of H2O is based on the tetrahedral shape with bond angles of 109 degrees. That's why, you know, they both, although they are both just 3 atoms, they have different bond angles. Go away. So yeah, there's a few questions like that as well, and these are very common questions in NCEA exams. So let's have a look at some exams. This is from last year, and this is a very typical question. Draw the Lewis structure diagram for the following molecules, CH4, NCl3, and OF2, and then name the shape. This will be a nice achieved question. And now down here we have the excellence question, where the above molecules have different shapes. However, each molecule has an approximate angle of 109.5 degrees. Justify the statement by referring to the factors that determine the shape of each molecule. So you're basically going to explain the shape of each one and why they all have 109.5 degrees bond angle. Basically, the answer is each one of these central atoms, carbon, hydrogen, and oxygen, have 4 regions of negative charge around them. However, they're different shapes because I've got different amounts of bonding and non-bonding regions. For your justify statement, you are pretty much going to have to explain the shape for each one. So something like this for each one, and then your final explanation saying, and then your final explanation saying why they all have the same angle. In 2018, pretty much the same question. Compare and contrast the shapes and bond angles of NH3 and BF3. Remember, BF3 is one of our exceptions. Compare and contrast means similarities. So both NH3 and BF3 have 3 atoms they're bonded to, or the central atom is bonded to 3 atoms. So that's going to be the compare, and the contrast is they have different bond angles, and you've got to explain why. In 2017, similar question. Instead of compare and contrast, it's justify the shapes and bond angles, but you're going to be doing the same thing. And for the last one, compare and contrast. So these are really, really common questions, nice and easy, and you can get excellence for this question here. So what I want you to do today is do these practice questions from page 54 to 57, 54 to 57. Like, it does look like there's a lot of writing there, and you do need to do a bit of writing, but once you get into the flow of it, it's going to be, it's going to be fairly simple. The important thing is just use this nice recipe here for your answers. Pretty much this, but changing what's in the gaps. And also make sure you're really answering the questions. I think they pretty much all have the same questions. Yeah, so that's all I'm going to be needing you to do today. And I will let you know when I'll see you next. We'll have an online meeting at some point, maybe Friday. Cool, all right. I'll leave you with that, and any questions or concerns, send me an email. Cool, thank you, and see you later.